Good morning, Said. Happy Wednesday. So today, obviously, we're going to do the notes and the I do's. Today's lesson is all about the distributive property. Yesterday, or yes, Monday, not really yesterday, we looked at the associative property and the commutative property. So, like two different of the properties of operations that we can use to help simplify different algebraic expressions. And today we're going to be doing kind of the same thing, but with the distributive property. So let's jump right into it. Let me share my screen. All right. That is, the camera is way off. All right. So we'll start with the title for today. Simplifying with the distributive property. U3L3. It is 7M, and today is the 4th. All right. So hopefully you guys remember the distributive property from last year, from 6th grade. I don't think you guys do it in 5th, but maybe even from then. But if you don't remember, it basically comes from the idea that if we have a number outside parentheses, and inside parentheses we'll have either addition or subtraction, it could be either one. But if we have a number outside the parentheses, we can distribute it to each of the numbers inside. We can multiply it by those and get the same answer as if we just subtracted them inside and multiplied it. There's the definition of this. The reason why I explained that first is the definition of this is a little confusing to think about, but the concept itself is not that confusing. All right, so we did our title. We're going to do a little subheading, properties of operations. However, if you remember, we started this in Monday's class, so I'm also going to put a little CONT, period, standing for continued. So this is signifying in my notes, because again, this will be something that you guys do as you go through high school, you go through college. This is signifying that you're continuing the same topic, the same subheading as you were in the previous notes. So in the previous notes, we had, just to belabor the point, we had properties of operations, and we listed a couple ones. All right. Here we have properties of operations, continued. Let's take one last look. I don't remember if I underlined. I did underline the properties. Okay, so I'm going to underline the name of the properties when I do it. So number 3, the third property we'll look at is the distributive property. Distributive property. Line dash. All right. So the way that I explain this in English is multiplying a coefficient, because remember, any number that's in front of something, usually it's in front of a variable, but could be in front of a parentheses. Any number that's in front of something is a coefficient. So multiplying a coefficient by a sum or difference is the same as multiplying the coefficient with each of the addends. And I say addends here instead of like addends, minuends, and subtrahends, because remember, if we see subtraction, we should always be write it as adding the opposite. So you should always end up having it as addition. But again, the distributive property is multiply coefficient by a sum or difference is the same as multiplying that coefficient with each of the addends, and then adding or subtracting them. So whether you add or subtract and then multiply, or multiply and then add and subtract, you should still get the same answer as long as you're correctly multiplying it. We're going to have a little addition here. I know this was a little bit of a long definition. But in other words, make this a little easier to understand and to connect it to the name distributive property, you can distribute a coefficient into any sum or difference. So again, it's outside parentheses. You can always put it inside. Multiply by each of the things inside. So there's two main methods for solving these types of problems. Two methods of solving. This method. And a method that really helps us connect this idea visually. And remember, feel free to pause the video at any time if you need to catch up on the notes or you need me to slow down. I'm sorry I can't slow down in person, but I do think that this will be the next best solution. Okay, so we have two methods of solving. This first method is called an area model. And it's helpful because it's a good way of organizing our workspace to help keep track of the numbers and make sure we don't make any mistakes with this. And I'm going to go over two examples with the area model and with the second method, the same two examples. Those examples are going to be 5 times 2x plus 4 and negative 3 times 4x plus 8. All right. So the area model involves basically making a box or a rectangle. You can think of it like a bar diagram if you remember those. So I start out, I don't need to make it that high. So in this case, I have a 5 on my left-hand side. I have a 2x up here plus 4. Now the reason why the area is helpful is because we know when we have a square, we find the area of a square by doing the side by side, or if we have a rectangle, times width. In this case, the length would be 2x and the width would be 5. For this box, the length would be 4, the width would be 5. So the area model is helpful because we already know that. So we know we have to multiply here. And it helps us keep track of that well because it's a neatly ordered box. So those are two really good reasons why we use the area model. It can be a little time consuming for some of these easier ones like this one. But especially if we're having any negative exponents, which that's one of the really big differences about distributive property period. We have to remember to distribute that negative to both of the factors. It's easily forgotten. It's one of the biggest mistakes we make. But because that's a big mistake to make, we should a lot of times use the area model to help it clear. In this case, again, we know it's just the length times the width. So 2x times 5, 5 times 2 is 10, and we know just x by itself. So 10x plus 5 times 4 is 20. So again, that one's pretty simple with the area model. Just 10x plus 20. However, the negative one gets a little bit more complicated. So again, draw a box. Again, we have 2 add-ins inside. So I'm going to split it into 2. Now, negative 3 goes on the left-hand side. 4x on top of the first box plus 8 on top of the second box. So again, I'm just multiplying. Well, negative 3 times 4x, negative 3 times 4 is negative 12. And again, the x just stays there. So negative 12x plus negative 3 times 8. Well, 3 times 24, negative times a positive is a negative. So that's negative 24. So I get negative 12x plus negative 24. And remember, if the negative is coming after an addition or after any operation, you want to use on it. However, in order to make this as simplified as possible, as easy to be as possible, usually we get rid of those parentheses and the extra plus sign, and I usually make it negative 12x minus 24. Right. So that's how you use the area model. Get both of these. The second way that we can solve this, maybe, I didn't mean to cross out area model there, but I like to underline it pretty darkly so we can make it stand out a little bit. Maybe if we do area model, okay, something like that, to help it stand out. Let's try that for the second method. The second method, it's kind of similar because it's a way to help us organize and keep track of what we're multiplying, because that's always the big key with distributive property. You got to keep track of what you're multiplying and multiply it correctly. And we call it the arrow method. Okay, so let me just say or, put that in parentheses. Arrow, almost misspelled arrow, Jesus. Method, there's my dark underline, or arrow method. Again, you don't have to do both, just whichever one you prefer. I'm trying to think about which one stands out more. Not sure. You guys let me know if you think which one stands out more. But again, for the arrow method, we're going to use the same two examples. We're going to use 5 times 2x plus 4 and negative 3 times 4x plus 8. We should get these exact same two answers, but we want to see a slightly different way of thinking about this, because it's always really helpful to know different ways to think about these. Okay, so for 5, 2x plus 4, middle, negative 3 times 4x plus 8. All right, what the arrow tells us, so I need to draw an arrow from the coefficient to both of the things inside. That sum is 5 times 2x and 5 times 4. This sum is negative 3 times 4x and negative 3 times 8. Now you don't have to rewrite it, but I do think rewriting is a good step most of the time, as what I just said, 5 times 2x plus 5 times 4, as well as negative 3 times 4x plus negative 3 times 8. Again, it just helps us keep track of it, but this step isn't necessarily totally required. The next step is writing it as 5 times 2x, 5 times 2 is 10x plus 20. All right, that matches. And here we get negative 12x plus negative 24. Oh, that matches. Let's just simplify it like we did above. Negative 12x minus 24. All right, so we got the same two answers. Whether you use the area model, again, we use the quiz and think about it as this side times the top, this side times the top. Or if you use the arrow method and draw arrow from the outside to each of the inside things, as the outside times the first one, outside times the second one, outside times the first one, outside times the second one. Either way, you should get this correct. Again, if the question asks the area model, you need to draw the bar diagram. You need to put each of the numbers. You put each of the numbers outside, put each of the numbers inside, and then box your final answer after you write it on the answer line if it's there. Similarly, over here, sometimes you have to take an extra step in simplifying. That could be like this, just eliminating the plus sign. Sometimes it involves fractions. Sometimes it involves just combining the last couple like terms. But no matter what, make sure that your last step is always, always, always simplifying. We're going to take the next couple moments to go through. God, I almost just had a panic attack. I thought I wasn't recording. That would be bad. We're going to take the next couple moments to go through the I do's. And then you guys will be free to start on the we do's. And I should be with you guys in a couple moments, hopefully. We'll see how this times out. They've been about 20 minutes. So I'm really hoping we get through review in the first 5 to 7 minutes, and then have like 20 to 25 minutes for this. And then I'll be able to work with you guys on the redos and IP. But let's get to the I do. Enough about my ambitions. All right, here. Item number 1, expand the expression. That just means we're going to distribute it in. Simplify if necessary. This first one, well, actually for both of them, we can use the area model and the arrow method. Area model, arrow method. And we'll just do it quickly for both. I don't want to take up too much of you guys' time. Arrow method. All right, so first of all, for this one, we have x times x minus 3. And a model, x minus 3. I'm going to show you 2 different ways to think about if we have negatives here. One way, or not negatives necessarily, sorry, subtraction signs, minuses, subtraction sign. I'm going to show you 2 different ways to think about it. The first way is just to leave it as a subtraction sign, and we can multiply, okay, x times x, that is x squared, minus, I'm just going to bring it down, 3 times x is 3x, and I get x squared minus 3x. All right, let's see if I get the same thing with my arrow method. Draw my arrow from the coefficient to both of the I guess these are minuend and the subtrahend. And you can think of it as addends if you rewrite it as addition first, but we're gonna do that for the second method. Here, a lot of times it's best to rewrite it as the multiplication first, so x times x minus x times 3. X times x would be x squared. X times 3 would be 3x. X squared minus 3x. We get the exact same answer. For item number 2, again, feel free to pause it at any time or rewind if I'm speaking too fast. If I'm going over something that you just don't understand. Also, feel free to write any questions down. Whether I get to you guys in the second half of math class or in specials, I want you to be able to ask those questions and to be able to address them. That's what you guys deserve. You guys deserve like my full attention and everything. So please make sure you guys are putting the effort there if necessary. All right, lecture over. Sorry. For the second one, I said we're going to do this a slightly different way with a subtraction sign inside. That slightly different way is to first rewrite it as adding the opposite. So subtracting positive 3 would be the same as adding negative 3. So first of all, I can make it negative 2 times 2x plus negative 3. And we'll have the double parentheses over here. That's okay. So again, I'm going to do that right here. Negative 2 times 2x plus negative 3. For my arrow model, for my bar diagram, split it in half. Negative 2 on the left side, 2x on top, plus negative 3 over here. All right. So now that's the basic setup for both of them. I'll draw my arrows. Don't ever forget to draw your arrows. The arrow method is the one I use most of the time, honestly, nowadays, because I've gotten used to multiplying. But if you're struggling with the multiplication part of it, with multiplying with what you're gonna get when you multiply, arrow model is the best way to use it. If you come up really well in your head, then the arrow method will be quicker and it'll be the best way to use it. So kind of different methods for depending on where your level of understanding's at. And remember, it doesn't really matter where it's at right now. Use the tool that's best for you and keep pushing forward and you're going to do awesome. All right, here we have negative 2 times 2x, negative 2 times 2. Well, negative times a positive is a negative. 2 times 2 is 4. So we get negative 4x plus negative 2 times negative 3. Oh, well, this time it's a negative times a negative, and that's a positive. Okay, so I don't need to put a positive sign. I just know it's positive. And 2 times 3 is 6. So that's going to be equal to negative 4x plus 6. All right, let's see if we get the same thing with the arrow method. Arrow method, we want to rewrite it. Negative 2 times 2x plus negative 2 times negative 3. Remember, I have parentheses here and not here because over here I'm following an operation. Anytime you follow an operation and it's a negative, we'll have parentheses around it. In this case, negative 2 times 2x, well, we said it was negative 4x plus negative 2 times negative 6. Sorry, Jesus, negative 2 times negative 3 is positive 6 plus 6. And it is the exact same thing again. All right, so whether you use the area model, the arrow method today, and some questions will ask for the area model, some questions ask for the arrow method, some questions will just leave it up to you. Which, however you use it, please make sure you draw it out fully. Please make sure you draw the arrows or the boxes, and box the final answers. Be careful with that multiplication. Again, remember, a lot of you will make this mistake. I'm sure of it, both like on the IP and in class. You'll forget to multiply the negative times the second part, or you'll say you'll forget that this is subtraction, and you'll end up putting x squared plus 3x. And technically, you'll be wrong, even though you got most of the problem right. So just be careful for those little things here that'll really throw you off. Otherwise, good luck with the videos. Good luck on the IP. I'll talk to you guys in a little bit, hopefully. We'll see. But again, make sure you save any questions for me. But otherwise, good luck working through these. Have a great rest of your day, 7th grade, and I'll see you guys in a little bit.